Hi everyone, welcome to lesson 25, the game design process. So our question of the day for lesson 25 is, how does having a plan help to make a large project easier? So we're going to talk about planning as we get into this lesson 25. So we start with bubble 1, and bubble 1 says defend your cake. This is an example of a defender game that you'll build by the end of this lesson. To defend your cake, move the alien with arrow keys to block the ladybugs and push them into the water. So do this. Turn to a classmate and make a list of the following information. If you were making this program, what sprites would you need? What variables would you need? And what functions would you use? So let's take a look here. So I'm playing my game. All right, I'm supposed to be blocking these ants. So I'm supposed to push them into the water. I'm not doing a very good job. There we go. Oh no, he's faster than me. All right, so what sprites would you need for this game? Think about it. Write them down. What variables do you think you're using for this game? And what functions are happening here? All right, pause if you need to finish your thoughts. And hit finish if you're done. All right, for bubble 2, we have a plan your project. Take a look at the project guide, which has already been filled out for you. Does the project guide describe the same sprites that you thought of? Does it use the same variables to store information? And are the functions that it describes the same as the functions that you described? So pause here and take a moment to look at the project guide. Okay, so the project guide should look like this. And so we have an overview here. Building a larger piece of software like a game can quickly get complex. Starting with a plan can help you stay organized and identify issues ahead of time. A lot of the work you do here will make it much easier to keep track of what you do once you begin writing your actual code. Gameplay and visuals. Start by thinking about what your game actually does. What does it look like? How do you actually play it? What will make it fun, interesting, or relevant to the player? Describe your game. In a couple sentences, describe the game you are going to build and how it will work. So this is the description for the game that we just played with the alien and the ladybugs and the cake. It says, you are an alien defending your cake from evil ladybugs. Ladybugs march across a bridge towards your cake. You'll need to push the ladybugs off the bridge into the water, get points for stopping ladybugs, and lose points for letting ladybugs get through. Then we draw the game. Draw a quick sketch of how your game will work. Who are the characters? What does the background look like? How do things move? Label things to make them much more clear. So we have a very basic drawing here. We have water, we have cake, we have the player, and we have the ladybugs with some arrows indicating that they are marching forward, okay? Then we have sprites and variables. Using the description of the game above, figure out what information and characters you'll need to keep track of through your game. Fill in a description for each in the space below. We have sprites. In the table below, list the information about the different sprites in your game. What are they where are they located? How do they move? And how do they interact with other sprites? So take a look. First we have a player. We'll call it's the alien. It starts at 300, 200. There's no rotation or velocity yet. And it says user and sprite interactions. What does the user control this sprite? How does it move? Does it ever need to reset? Does it interact with other sprites, and how? So arrow keys move the sprite in 4 directions, and it does displace ladybugs. Then we have our cake, labeled cake. There's the starting point with no rotation or velocity. It never moves. When ladybugs touch it, you lose points. Then we have enemy 1, which is called ladybug. And it starts in this location with a velocity. And then we have a notation here that it may need to move faster. Then here's the notation for what it does. It moves across the screen left to right. Player sprite can displace the ladybugs. If they hit the water, reset and give the player a point. If they hit the cake, reset and remove 5 points. Then we have ladybug 2, enemy 2. Starts also at 0 and random Y. Has a velocity of 2, and then the same as above. Now down here for variables, it says think about the information your game needs to keep track of. Is there a score, a number of lives, describe each variable. So we have a score, we have player score, we start at 0. When ladybugs push in the water, we get a point. When ladybugs hit the cake, we lose 5 points. Now here's the functions. So your draw loop shouldn't have a lot of complex code. Instead, break your program up into the major steps you'll need for your game to work. The different behaviors you described in your sprites and variables should help you decide what these steps should be. Then describe what the code for that function should do. So we have a function name here called game background that draws the background. We have a function enemies touch cake, which resets enemies when they touch the cake and decreases the player's score. We have a move player, which moves the player with arrow keys and changes animations. We have a displace enemy, which player pushes the ladybugs. We have an enemies touch water. If the ladybug touches the water, they get reset and the player's score increases. And then show score, which shows the score on the screen. And that's it for this particular project guide for the ladybug game. Okay, so let's move on to level 3. So in level 3, it says before you get started, you'll want some better animations for each of your sprites. Do this. In the animation tab are animations for each of your sprites. Go look at what they are. In your code, give each sprite its appropriate animation. Use the ones provided for now, but later you'll be able to go change them. Okay, and then remember, this symbol means that this project is going to be linked to other projects at other levels. Okay, so let's take a look at what animations they've given us. We've got an alien walk right, a cake, a ladybug. Ooh, it's a very moving, it's an animated ladybug. And that's it. So alien, cake, and ladybug. So what we got to do? Give each sprite its appropriate animation. Okay. So what did I start with? I start with a bunch of blank spaces. So we have variable score, variable cake, variable player, variable enemy, and enemy. So we've got to assign some things here. So cake should look like cake. Player should look like alien. Enemy 1 should look like ladybug. And enemy 2. Computer is very laggy today. Enemy 2 should also look like a ladybug. So let's see what I got here. Okay, so far so good. So good. Variable anyone, create sprite. There's my background. There's my functions. Okay, so do I need to mess with those just yet? In your code, give each sprite its appropriate animation. Use the ones provided for now. Okay, I think I'm done at this point with this level. So as always, pause if you need, or hit finish if you don't. Da-da-da! Bubble 4 says moving the enemies. You'll need to get your enemy sprites to a random position and moving across the screen. Do this. After each enemy sprite is created, set its X position to 0, set its Y position to random number between 150 to 250, set its velocity, X velocity to 2, then test. Each enemy sprite is created. Okay, so I'm working on the ladybugs here. X is 0. Okay. X is 0. Enemy touches. Okay. So here's what I think I need to do. I think I need to go here. So enemy X. Enemy 1. X is 0. They said enemy 2, enemy 1, Y. Enemy 1, Y is random number. And they said 150 to 250. And then they said velocity X set to 2. Uh-oh, I had a glitch. Let me refresh my browser window. It happens sometimes. We all have a little glitch every now and then. Nothing wrong with that. Alrighty, let's see here where I left off. Okay, so enemy 1X, oh my, it really glitched. Is 0. Enemy 1Y is random number. I know it feels like Groundhog Day because I just did this, but I glitched and lost the code I had written. And then we need to add a velocity X. Enemy 1, velocity X gets 2. So what did I just add? I added line 12, 13, 14. I added enemy 1X gets 0. Enemy 1Y gets random number, 150 to 250. And enemy 1 velocity X gets 2. That's what they stated here in my do this section. And so now I need to do the same thing for enemy 2, but watch this trick. I'm going to go to show text. I'm going to highlight those 3 lines of code that I just created. I'm going to Command C for copy. I'm going to come down here to var enemy 2, and I'm going to Command V for paste, V as in Victor. And now all I have to do is change my enemy 1 at line 18 to enemy 2, enemy 1 at line 19 to enemy 2, and my enemy 1 at line 20 to enemy 2. Okay, so what did I just do? I've done everything from line 11 to line 20. I've added an X position, I've added a Y position, and I've added a velocity. So what is going on here? Why does it appear? Oh, there we go. So it had randomly selected the same position last time. That's kind of cool. All right, so I have 2 ladybugs and they are on the move. Did I satisfy my requirements? Yes, I did. Okay, so here's the screen again. We worked on lines 11 to 20. If you need to continue to see this screen, hit pause. Otherwise, hit finish. Da-da-da! All right, now we're going to be moving left and right. Now you'll just need to get your character moving left and right to change and changing its animations. Do this. Inside the move player function, okay, so we're using the move player function. Scroll down here. Inside the move player function, so here we are. You're going to use a conditional to detect when the right arrow is pressed. Okay, so here's my conditional. So if what, if key down which direction, right. Okay, so if key down right, we're going to move sprite to the right by 3. If key down right, move sprite to the right by 3. Okay, if key down right, then player, which is our alien, velocity x 3. Okay, if key down right, player velocity x 3. Let's test it out. Does he move to the right? Yes, he does. Okay. Use another conditional to move the player to the left when the left arrow is pressed. Okay. So if I did this for right, I'm going to do the same thing for left. So if what? If key down left, then player velocity x, because x is left to right. Now, if I did a positive 3 for moving to the right, I'm going to do a negative 3 for moving to the left. Reset and run. Okay, I'm testing it out. Move to the right, move to the left. Okay, so far so good. It says test your game. Your character sprite should now move left and right when you press the left and right arrows. And it does. So if you need to pause to take a look what we did, we added lines 50 to 55, 2 if statements with key down right and key down left, and we added a velocity x positive 3 and a velocity x gets negative 3. Pause if you need to see this code, hit finish if you do not. Da-da-da! All right, level 6. Now we're moving up and down. You'll want your player sprite to move up and down as well. Inside the move player function, so we're still in the move player function that we just did in bubble 5. You scroll down here. Here it is. It starts at line 49. Use a conditional to detect when the up arrow is pressed. And if it is, move the player sprite up by 3. Okay, so just like left and right, I'm going to grab an if what, if key down, up. Now, up and down is a velocity y. If we use x for left and right, we're going to use y for up and down. So I'm going to go sprite velocity y. Here's the question. Is it a positive or a negative? Hopefully you remember that as you travel up, your y value will decrease. So that means I need a negative 3 for the up key to work. Let's test it. Yes, it works. Now we're going to do the same thing for the down arrow. So if key down, and we want down, then we're going to go player velocity Y, player velocity Y. If up was a -3, Y down will be a +3. Now let's test our motion here. I go up, I go down, I still go left, I still go right. Okay. So it says, use another conditional to move the player down. We did that. Test your code. Your character should now move in all 4 directions. Okay, it does. It does move in all 4 directions. So in this bubble, we just updated up and down, lines 56 to 61. If you need to pause to see the code, go ahead. Otherwise, hit finish. Da-da-da! All right, bubble 7 says change player animations. You can change the animation when the player changes direction. Inside the animation tab, copy the animation of your player sprite. Flip each frame of the new animation so that the sprite is facing the opposite direction. Rename your new animation. Inside the move player function, set the sprite's animation so that the player changes direction it is facing when the left and right arrows are pressed. Okay, so I'm going to go to Animation tab. This is Alien Walk Right. I'm going to hit this Duplicate button. Now instead of Alien Walk Right Copy, I'm going to change this to Alien Walk Left. And how do I make sure he looks left? Well, I'm going to use this little, looks kind of like a volcano to me. And it says flip vertically. So I'm going to click that once. He changes the direction he's facing. Then I have to click the second animation and flip that. So now he's got a left facing and a right facing. So according to my directions, I have to make him look in the direction that he's walking. So here's how I pull that off. I'm going to go down here to the move player. So if key down right, we're going to set player animation to Alien Walk Right. And if key down left, we're going to set animation to Alien Left. So now let's see what happens. Let's see if I can make this a little bigger for you to see. If I go to the right, he looks right. If I go to the left, oh, lag is real, ladies and gentlemen. Lag is real. Lagging. Let me refresh. I'm lagging. Internet is rough today at school. I'm so sorry. Okay, let's try this again. The screen a little bigger. Hit run. We go left. He looks left. He goes right. He looks right. So very good. So we have him looking in the directions that he needs to look. All right, so we are done with this level. Again, we were down here under the move player function, line 49. For key down right, we added player set animation, Alien Walk Right. And for key down left, we added player set animation to Alien Walk Left. Pause if you need to see those lines of code. Otherwise, hit finish. Da-da-da! Now we're going to do the touching of the cake. If the enemy get all the way across to the cake, you should place them back at the left side of the screen and decrease the score. To start, you'll write code for only one of the enemies. Do this. Inside the enemies touch cake function, okay, let me find that. Enemies touch the cake. Right there it is, line 45. Inside the enemies touch the cake function, use a conditional to detect whether enemy 1 is touching the cake. Okay, conditional. There's my control. if statement. So if player 1 touch cake. Okay, we've done this one before. I'm going to the sprites drawer. I'm looking for the touch. There it is. So if enemy 1 is touching cake, then we're going to reset. We're going to reset enemy 1x. Zero. And we're going to reset enemy 1 y to random number 150 to 250. Whoops. 50 to 250. And let's see here. Use the counter pattern to decrease the, okay. So we gotta do variables. So score is also going to get score subtraction. Whoops, not core. Score minus 2. All right, let's see if I got enemy 1 working correctly. So we're talking about one of these little boogers up here. I don't know if it's this one or this one. One of them is enemy 1. Let's see. Oh, the score went down by 2. Now let's watch and see. And it did reset, so that's good. It did reset. Reset again. Okay. The score does go down by 2. So far, so good. So if you would like to pause to take a look, what we did here is we created line 46 to 50. We added an if statement. If enemy 1 is touching the cake, then enemy 1x gets 0, enemy 1y gets random number, and the score goes down by 2. Pause if you need to see the code, otherwise hit finish.